Hello all. So in this lecture, we are going to read about read commit isolation. Okay. So what is read commit isolation? So in a typical database, a database is basically working with multiple threads. Let's say thread one is writing something at T1. Okay. Thread two is reading something at T2, and again it is reading something at like T3. So this all things can happen, okay, but it is not guaranteed that it will happen in the same sequence. Like W1 can happen after W2, or W1 can happen after R2. Okay, so what we do, I mean, what can happen then? There can be a lot of race conditions. It can happen that maybe this guy is writing and this guy is also writing at the same time, and some uh, bizarre thing, some corruption actually happens, right? This can happen. So what we do in this scenarios, there is a term in the acid video. I have kind of explained it, but I have not made it official. It is commit. It is commit. Okay. So what this commit means, let's say there is a thread. Okay. Let's say there is a thread which needs to do two tasks, like writing something in DB1 and then writing something in DB2. If both of them pass, then the task is good. If one of them even fails, then we will say that roll back the whole thing. Okay. So what commit means, that we won't write in this DB. Okay. Once the both changes are done, then only we will write inside the DB. Then only we will make it permanent, or else we will just keep it in memory until the whole thing is passed. So let me give you some examples, and then we can understand it better. So let's say there is a shop, okay, which is selling cokes, and there is only one coke left. Okay. So what I did, so this is me, this is Donald Trump. Okay. So what I did, I went to the shop, checked if the coke exists or not. So coke exists. So I told, uh, make a change where this coke is ordered for me. Okay. After this is T1. Okay, time 1. At this time 2, Donald Trump also went to this shop. He checked, does the coke exist? Yes, the coke exists. So he told, make the changes for Donald Trump. So in the first one, in time T1, the coke is done for me. In time T2, it is done for Donald Trump. Okay. Then in time T4, what happened? My internet speed is slower than Donald Trump. So time T3, Donald Trump told that send this coke to Donald Trump at White House. Okay. So send this coke at T3 at White House. Okay. And in the time T4, I told, send this coke to me at my home's location. Okay. So in my home location. Okay. Now what happened in this scenario? I told in the T1 that assign this coke to Akash. Okay, so it got assigned. Then Donald Trump also told that assign this coke to Donald Trump. So Akash got replaced by Donald Trump. Okay. Then in time T3, Donald Trump added his address for ordering. Okay. So let's say it is White House. Okay. And at the time T4, I told send it to my home. So House got replaced by my home. Now what happened? This order got ordered by Donald Trump. Okay, Donald Trump at my home, which is wrong. Correct. So what can we do to prevent this scenario? What we can do, as soon as I queried it, I should get a lock on this coke. Okay, so let's say this is the database. Okay, I should get, yeah, this is wrong. So as soon as I queried and I said that set the name, I mean order name to Akash. Okay, what happened? We get a lock. So when Donald Trump comes, Donald Trump, like he's a cool guy. So yeah, when Donald Trump comes, okay, he didn't get the read. Why? Because I already have the lock. In this condition, what happens once I complete the whole transaction, like make this coke on my name, like order this coke on my name, and add my address as my home. I got the coke. Donald Trump didn't get the coke, so he didn't lost anything. Correct. So this is called, this whole thing is called, this problem is basically called dirty right. Okay. So if my changes were replaced by Donald Trump's change, and then Donald Trump's address is replaced by my address. Okay, that problem is called dirty right. Okay. Now problem number two. The problem number two is dirty reads. What is dirty read? Okay, let me think of an example. So let's say this is me. Okay, and this is the shop who is selling the coke. Shop is selling the coke. So I have seen the coke. Now I paid him like $10. Okay, $10. And then let's say $10 I have paid in time T1. Okay. At time T2, I'm checking my balance, which is, so previously I had 100 rupees. Okay. So now it is minus 10 equals to 90 rupees. Okay. Okay. Which is nice. I have $10 less. Okay. But what happened that, let's say the store was having like $100 also, and when I paid it should have plus $10, but because of some reason this plus $10 didn't get added. So he still have $100. He still have $100. Now he checked that did I get the payment. He see no, I didn't yet receive the payment, so he cancelled the order. Okay. So what happened? I lost $10, but I didn't get the cook also, which is bad. So this is called dirty read, because when I am reading, I am only having $90, right? So this is called dirty read. I am reading the wrong thing. So how can we ignore this? How can we don't have this problem? Is by, when I made $10 change, okay, it is stored somewhere in memory. Okay, it is not yet committed. It is not yet like permanently written on somewhere. Once the store, once the store receives the payment, then only uh, receives the payment. So let's say this is where the whole database is. Okay, once the store receives the payment, then only from memory we send all the writes to the database. That is, from my account there is minus $10, from the store's account it is plus $10. Before that we don't write it to the memory. If something fails in between, we just reverse back, because reversing from the memory is very easy, right? So this problem is called dirty read. Okay. You could have, now the thing is, you could have also said that when we are getting dirty reads, why store something in memory and later on writing it to the DB? We could have just locked the particular row, right? We could have done that. Yeah, that is true. But let's say we locked the row for the store, and someone, so this is me who locked this particular row. This is all the details about the what how much amount of money the store has. Okay, and then a third person came and he also ordered something. Okay, but he can't order. Why? Because this lock is already taken by me. So in dirty read kind of conditions, it's better not to take the lock. Why? Because this make the whole application extremely slow. So it's better to like save it somewhere in memory, and once the whole transaction is done, we can directly write it to the main DB or whatever the main storage is. We can basically commit the data. Okay, so remember this word commit. So yeah, this is the video. So any database which takes care of uh, which takes care of like dirty read or write, any database which takes care of this dirty read or write is having that read isolation. Okay, read commit isolation. So that is the video. Thank you.